Well, hello, everybody. Good morning, good afternoon, good evening, good night, wherever you are in some time zone across our lovely world. Thanks for joining us here live today for the one and only Serverless Office Hours. We are streaming on the AWS Twitch channel and also on the AWS Events channel from YouTube. So welcome wherever you are joining us from. My name's Julian. I'm a developer advocate for serverless here at AWS, and we have some rejoining guests as we continue our series of looking at all the awesome things that have been coming out from AWS Serverless at reInvent and a little bit before in pre-invent. So Rohan, welcome back to Serverless Office Hours. For people who don't know the awesomeness of Rohan, tell us about yourself.
Yeah, thanks for having me on again, Julian. So I am a serverless specialist, solutions architect. A lot of words in that title. I honestly, flub it. It's like a tongue twister all the time. But I help our service teams connect with both the field and the AWS customers, understand how the services are being used and how they can make them even better.
Cool, excellent. Welcome back, and Nihar also welcome back as well. For people who don't know Nihar, Sheth, tell us about how you landed up doing what you're doing today with AWS Lambda.
Hey, folks. Thank you very much for attending this session. Thank you, Julian, again for organizing this and inviting me to Serverless Office Hours. My name is Nihar Sheth. I'm a product manager with AWS Lambda. I focus on event-driven workloads and async invokes for Lambda. Super excited to share with you some of the launches that we have done in the last few months in the space of event source mapping.
Cool, excellent. And as I said, we're doing a series of all the new things at reInvent. Two parts of it. One is some of the cool announcements that have happened recently. So last week we looked at Lambda Managed Instance. API Gateway Response Streaming. We've looked at Lambda Managed Instances in December. We looked at durable functions. And we've got lots of cool things coming up as well. Especially one of the hidden secrets of reInvent, I think, is Chalk Talks. So Chalk Talks, if you're not aware, these are these small, intimate rooms, 60 people about, and it's basically 10, 15 slides, questions and answers, but they're not recorded. So you can't get them on YouTube. You can't get them anywhere else. But we're getting people to come and do some of the Chalk Talks here on Serverless Office Hours. So you'll be able to answer your questions from some of our top experts at AWS that we'll be having over the next few weeks as well. So I'm super excited for that. As well. We do have some people on the chat. So Heggy Park, who's also an awesome colleague of ours at AWS, first up with hello. Ramesh, thanks for joining us via YouTube. Welcome. And a personal hi, Rohan and Nihar from Ishit Chakraborty, who's joins us regularly on Serverless Office Hours. So it's lovely to see some returning people. Please tell us where you are and what you're doing and what you're most interested in of what's come out recently. We love seeing our global serverless audience, and it is amazing to see where people come from in any way around the world. So welcome. So I've already lost track, but I think we were going to start with Nihar, who is going to tee up sort of what event source mappings are and all of that. So we've got Nihar and Rohan's info up on the slide over here. But yeah, Lambda event source mappings. For people who don't know, Nihar, what are event source mappings?
Absolutely. So event source mapping is a dedicated Lambda resource that connects your SQS, queue, or Kafka or Kinesis stream to your Lambda function. It enables polling events or messages from your sources and invokes your function with a batch of records. Underneath, it has a capability for filtering, batching, sometimes retry and error handling before your function is get invoked. It's one of the most powerful and I would say hidden gem within a Lambda capabilities. We support 7 different event sources. SQS and Kinesis, DynamoDB are one of the most popular ones. We see Kafka event source adoption from customers throughout the world. And we are super excited for capabilities that we are launching for Apache Kafka event source. Now, here I want to compare some of the capabilities across various event sources. There are 3 primary groups event sources that we have a capability. One is SQS, one of the oldest. Second, Kinesis and DynamoDB both have the identical capabilities, and third is MSK and self-managed Kafka as event sources. We launched a provision mode for both Kafka in 2024, and we launched it for SQS just few weeks before reInvent. Let's dive deep into a provision mode for SQS. Hundreds of thousands of customers already use SQS as an event source with Lambda. It's one of the most popular event source. They love the auto scaling capabilities based on the backlog of messages in their queue. However, the default SQS ESM scales at a rate of 300 concurrent executions with a maximum concurrency of 1250. So when customer have a extremely spiky workloads and require a low latency, those workloads were finding the latency up to few minutes when the traffic pattern increases drastically. So we launch a provision mode to allow this specific customer to control the polling throughput or polling resources that is supported for their provision mode. This is think of this as like a provision concurrency, but polling resources. With this capability, we allow 3x faster auto scaling, up to 20,000 concurrency, which is 16x more than our default SQS ESM. Latency, your customer will see a predictable latency depending upon their traffic pattern. Yes, this is a paid capability. It costs around 1 cent, little less than 1 cent per event poller. So as a part of that experience, you configure how many event poller you need as a pre-warm capacity, and you pay for those event pollers. And when we scale up, you pay for the whatever the scaled event pollers are. Rohan, do you want to show the demo of this amazing capability and how quickly it can handle the spiky workloads?
I would love to, Nihar. There's
Cool.
nothing
Excellent.
more I would love to do.
We will switch over. And Kian, just to share your screen, and then just Nihar, I think your microphone is maybe just tapping on your lovely collars. So if you can move it up slightly, that would help with some of the signing. And yeah, I just want to while Nihar is doing that as well. I just muted you, Nihar. So if you do say something, we'll bring you on. But I think SQS and Lambda is just such an awesome event source mapping. Because it's not just about, oh, this is something else that Lambda can pull from SQS. This is a sort of fundamental building block for building event-driven applications when you need to, do decoupled systems, you're building microservices, you are wanting to, move data around your organization. SQS as one of the first serverless services, let alone AWS services, is fundamental to that as well. And so, that's just doing communication between different microservices. SQS is great. A data sync to be able to do batching and to be able to, you dump a whole bunch of stuff in SQS, and then just it acts as a data sync where you can control your throughput and allows you to just throw, basically SQS is crazy because it's unlimited, and then you point Lambda on it and you can control how Lambda can consume it. And that is awesome for protecting downstream APIs, for connecting to databases to not overwhelm things. And so it's got this sort of incredible buffering capability that can be used. And even though we're going to be talking about provision mode today as well, this is all, SQS works at ridiculous scale, as I've already said. And I was just doing some quick back of the calculator app on my laptop. So Nihar said, 1,250 is the concurrent number of Lambda functions that can run in normal mode. So it's like 1,250 event processes, just out of the box. You don't pay for anything more. That's incredible. Say each of those, you sort of did a batch of maybe a batch of 10 messages that need to be done, and they would each take 100 milliseconds. This is common. SQS messages are often smallish. They can get bigger now. Another thing we'll talk about. And you're sending them to a database as well. So you've literally got 1,250 times 10 And that's already 12,500 records per second that is being processed. I mean, that's a massive amount of data being able to process through everywhere. So when Nihar talks about, well, we've increased it to 200,000, 200,000 messages per second, this is ridiculously high scale. And so, yeah, just, the two ends of this, how Lambda can really be powerful and really be cost effective at low scale, which is up to 12,500, same messages a second in our example. I mean, that's massive. And then obviously going up as well. So I just wanted to give a bit of a punt for the whole sort of SQS and Lambda together, because it's a way bigger story than, we've got event source mapping, we've got some more sort of little tweaks and knobs that you can put together. The story is fundamental to how the cloud works, because the cloud is so infinitely scalable, having something like SQS as this buffer, as an architectural concept is just exceptional. There's a whole bunch of stuff you can do in SQS, and tying it with Lambda is just a marriage made in heaven, is how I think about it.
Oh, 100%. Thank you, Julian, for giving that great context. You are absolutely right. Even before this provision mode, SQS ESM was great. Now it is just unbelievably great. Yeah. And the way I think about it is that if you have a very spiky workloads with your SQS queues, and you are getting a queues from upstream services where you don't control the traffic pattern, with the provision mode, the scaling capabilities that you are getting, there is no way you can build it in a non-Lambda environment, right? Whether you want to build it on EC2 or Fargate or any other compute, just not possible, because the scale of both compute and a polling that it can be supported is just unbelievable.
Yeah, and I mean, there's a lot of nuance and a lot of deep dive. In fact, I will share the video. There's a lot of nuance and a lot of deep dive behind the scenes as well, because Nihar talked about all the different event source mappings. We've got SQS and we've got Kafka, Kafka in two flavors, self-managed or MSK, and the self-managed can be Confluent and it can be Red Panda, and all the other, everyone who provides Kafka, which is awesome. It's not just AWS kind of things. Then, a lot of DynamoDB Streams and Kinesis and, Amazon MQ and RabbitMQ, all these kind of things. But behind the scenes, this is a massive polling fleet that AWS just manages on your behalf. They've all got different libraries, the Kinesis client library, the Kafka client, the SQS client, all tweaked, all optimized to make the best decisions, handles batching, handles filtering, handles, what am I missing out? Schema registry for Kafka, all these kind of things. And you don't have to do anything. You just get a JSON batch that pitches up in your Lambda function, and and there's great examples like the whole Kafka world is Java. Java's an amazing programming language. But previously, if you were like, well, actually, I I'd like to consume my Kafka in Go or Rust or PowerShell or Python or TypeScript, it's like, now I need to get a polling library that's going to poll from Kafka in all these other languages. That's hard work. Lambda event source mapping handles all the polling for you. Whatever language you just get your JSON payload sent to you, and you can just use TypeScript without having to even know that Kafka is, predominantly Java. So I am rambling on, but I get very excited about all the cool things that happens behind the scenes. So what I'm going to do is I'm just going to post in the chat, and this is entirely self-promotional, because actually I did a whole talk at I just need to get onto the Twitch on. I will do that shortly while Rohan's showing his demo. But I did a whole talk with one of our principal engineers who literally builds the polling infrastructure under all of these event source mappings. And we did a 400 level deep dive with vast amounts of information, not just on how all Lambda works under the hood, but also the reasons and the lessons we learned in building the polling. So yeah, Rajesh Kumar Pandey, super principal engineer. He's been on Serverless Office Hours before. So I'll put that in the chat, and then I will keep quiet because Rohan is way more interesting, awesome demos to show.
Oh no, of course, your material is very interesting as well. With that being said, let's talk about the demo I built to show off the capabilities of SQS provisioned mode, or sorry, ESM for SQS provision mode. So what I built using the help of our good friend Kiro. If you haven't downloaded Kiro already, it's an agentic IDE built by AWS that allows you to build new apps really, really quickly with the help of this trusty LLM here. So what I've built is a test. One Lambda function is running on the standard ESM for SQS. So that's a standard scaling behavior that we know from previously. And then now I have a second Lambda function that is a provisioned ESM for SQS. And as Nihar mentioned, it's able to basically have all these pollers ready to go, ready to process messages before the messages even start coming in. And what that allows us to do is process those messages much more quickly. So in the test run that I did, first I put in 2 million messages into the queue. And so we start with the standard queue. We wanted to see how long it would take to basically hit our Lambda account concurrency limit, which is, of course, 1,000 functions. And then we want to see how long it would take to process with that 1,000 concurrency. And then we switched over after that test run into testing the same load, 2 million messages, with the provisioned processor that had the provisioned ESM. And so it already had a higher number of minimum pollers that would be reading messages from the queue. And of course, it can scale up if needed to process additional messages from that queue. And then we wanted to see, okay, how long is it going to take to burn down all these messages that are coming into our queue? And so the logic that we actually have in the processor functions is, very simple, but they're all publishing metrics to our CloudWatch dashboard so we can see some of the insights from this test run. And so all of what I've built today is, of course, with the assistance of Kiro, which I found very useful as a developer. Of course, I could write this all on my own, and it's not too complicated of both the IAC and the application code to set up. But Kiro makes my job a lot easier, and it can also generate these kinds of diagrams for you. So you can, of course, stick this in your home directory of your repo, and so that your teammates later on, they can see these visual diagrams and have a better understanding of what both you and your IDE created. So quick pitch for doing that as part of your development practices. Any questions from Julian, Nihar so far?
No, I think we're good. We're all excited to see. I mean, and just like this is 2 million messages. This is also 2 million is a massive amount of messages as well. They're not many applications that are also going to be generating a bunch of 2 million messages. So yeah, I love the scale opportunities here.
Exactly. So for the sake of the performance run, this we have a Lambda function that's just creating all those messages. But of course, it can come from a variety of upstream data sources that customers may have in their wider portfolio of IT infrastructure.
Yeah, I seem to remember even online there's because it's something I've used before. I think it's something called something on GitHub called SQS Cannon, I think, or something, and that can also just shoots like a cannon, shoots messages into your SQS queue. So I like the name. It's always memorable.
That's good to know. Yeah, I will consider using that next time. So now let me switch over, and I want to show the results from my previous test run. And let me pull up that page. Okay. Yep, so here we have the Lambda function that is our provision processor. And of course, we can check out the CloudWatch metrics on each Lambda function page, which you can see the results of my test run here. But again, thanks to the Kiro, I was able to generate this CloudWatch dashboard, which I think I need to share this tab instead. Perfect. So making these dashboards is also another great use of Kiro. As a serverless developer in the past, I had to hand make these, and learning the syntax for how to do that properly took a bit of time. But I will say it's a lot easier now in 2026.
So is that using prompting to create, CDK or CloudFormation, or the commands to create those dashboards?
Yeah, so I used a prompt to say, hey, okay, now that I already have my Lambda function application code and the infrastructure definition for that, I was using our good buddy Sam. And so then I said, okay, here's another prompt. Can you make a CloudWatch dashboard that helps me track the performance of both my standard Lambda function as well as the provisioned Lambda ESM, and compare the results of those two? And it was able to generate all these graphs for me. And then I also fed it the details of the previous blog post that we did for provisioned ESM for Kafka to give it further guidance and context about how to structure this dashboard.
Cool. So that's actually then building it as the dashboard as part of the SAM template. So it's not just ClickOps in the console or something like that. It's actually building so you could move this application or build other kind of things in its proper infrastructure as code.
Exactly.
Love it. Yeah. Love it. So see, and because there are also MCP servers where you can talk to CloudWatch directly and get metrics and set metrics and do dashboards. So that different ways to be able to do this. But obviously our AI overlord robots are super helpful. Love it.
That's right. They are very helpful. So if we want to double click here and check out the previous test run. So this blue line is an example where we had 2 million messages coming in to the standard queue, and I will expand that right here. So right there. So with 2 million messages coming in, it still takes time for the standard ESM to have enough of the pollers, kind of ready to go and start processing messages. So it took, a few minutes for us to actually scale up to that max concurrency limit for our standard function. So that is one change in behavior that we then see here. You can see the orange line a little bit at the top where we actually start out at reaching max account concurrency. So instead of having to wait for all these pollers to be warmed up, those pollers are ready to go. And I think in this CloudWatch dashboard, it might not be showing like the exact number of pollers that were there at that start of that test run, but from what I saw yesterday, it was only about a minute to get to max capacity, whereas for provisioned ESM, whereas with standard ESM, it took about 4 minutes. So that initial spike and handling that initial load of messages was about 3 to 4 times as fast with provisioned ESM. And so when you have those latency requirements that require you to process those messages as soon as you can, handling that initial burst and getting those pollers ready to go, that's what provisioned ESM can provide you. So that's one key thing to note.
Just on the label there for provision concurrency, that's not actually Lambda provision.
Yeah, that's a good point. So I think, and that's a good example. As these LLMs are making these tools for us and making CloudWatch dashboards, we want to make sure that before we go to production, we are able to, properly label things that the LLM produces for us.
So yeah, that's just a label that it's.
Yeah, correct. That's a good catch. And, honestly, that's a great learning moment for our viewers, right? Even us at AWS, we're susceptible to those things. So you always want to make sure that you can keep track of what the LLM is producing for you.
Well, I'm going to say this publicly because Rohan earlier today, completely separate from this, I released a video on Lambda managed instances. And I called the title Lambda Durable Functions, but it was all about Lambda Managed Instances. So I got my label wrong, and I wasn't using any AI in it as well. So the robots in my brain had made the same mistake. But Rohan was the clever one who spotted it. So,
we all have each other's backs, right? So this is the function with provisioned ESM's concurrency. Okay. So we see that's like it reached the max concurrency, pretty quickly there.
So you could have also increased your account concurrency and then gone up to the 1250. So just
exactly, right? So then we could have gone through the entire backlog of messages that was being produced by the producer function even quicker. So that would have been a great way to handle it as well. And then I think if I wanted to reach the max concurrency of the whatever AWS can provide, Nihar might have had to approve that ticket in the back end. So I was trying to save him the headache of doing that.
Yeah. And another thing that I want to mention, and I think we always talk about a scale, right? I think, Julian, you gave an example of 1200 TPS, 100,000 TPS. This feature can support 200,000. But many customers, many of you in the audience, are working with a few thousand TPS, few hundred TPS. Even there, latency matters. I have a customer who has a few hundred TPS that gets a spiky. So baseline maybe only 10, 15 TPS, but then every few minutes or few hours, they get a TPS of a 200. That's a 10x spike. And even whether there is a 10 TPS request coming from their users or whether it's a 200, they want a latency which is a sub-second latency. In that case, this provision mode for SQS ASM is very important. So you target, hey, look, your peak is 300 events. This is the number of pollers you need to provision, which is like your warm poller. So if the spike happens up to then, your warm poller will take care of things. Of course, if the traffic unexpectedly goes above 300 TPS, as an example, let's say, then there would be faster auto scaling, as Rohan is mentioning. So even for a smaller workloads, this capability for a latency sensitive workloads is very, very important.
And a lot of people, I think, also use SQS, in a batch kind of mode where they're going to dump. I know, like S3 notifications, or I had an example of someone who was doing even an LLM inferencing, and they were literally dumping links to, I think it was like 100,000 record, even 1,000 records into SQS, but they were doing it at a particular time. And so you don't have to have a provision mode for SQS necessarily running all the time. You can use your scaling and whatever things to bring it up when you need it. You're going to do something at 10 o'clock every morning. You've got financial transactions that need to super low latency, and instead of thinking, oh, SQS is going to be a little bit slow in getting them, set up your provision mode ESM at the time that it can ramp up, and maybe only a few minutes, and then you're ready to rumble, and you can get really low latency with SQS as well.
Yeah, that's right. And the IAC definition for adding provision DSM is super easy. It's like 2-3 lines, and so it's just a very easy experience that Nihar has made for our customers.
Absolutely. Okay. Yeah. Let's jump into next set of capabilities. Thank you, Rohan, for great demo and a discussion.
Nihar, do you just want to share your screen? Your screen is shared. Do you want to just go full screen and then I'll bring it up?
Yes.
There we go. Okay, we have your cost optimization for provision mode up.
Perfect. So now you are aware of a SQS provision mode for SQS. We actually started our journey with this provision mode with the Kafka event source mapping. So we launched a provision mode for Kafka in November 2024. And adoption and from our customer was amazing, especially high throughput customers, 20 MB, 30 MB per second of throughput. Customers were super excited. They were able to use it. Similar kind of a capability like SQS we mentioned, faster scaling, low latency. You control how much warm capacity you have. Now, what happened is, as we talked with a large and medium scale and small customer, is, hey, cost was a big barrier with the provision mode for Kafka ASM, especially for a low throughput customer. If you have a throughput of 1 MB, 2 MB, still you had to pay for at least 20 MB of capacity with a provision mode. And new features, all our net new features on a Kafka ESMs were coming on a provision mode. So the customer saying, hey, look, I want a feature XYZ coming on a provision mode, but the cost is a big barrier. So we launched a cost optimization capability. There are two specific cost optimization capability that we launched as a part of in November. One is previously we were grouping 4 event pollers into a billing unit called EPU. So EPU stands for Event Poller Unit, which is basically compute resources where we put multiple event pollers. So before this launch, we were putting a 4 event poller within that one EPU. But when we looked at our traffic pattern across our customers, we saw that safely we can put up to 10 event pollers within a EPU. So the EPU cost per hour is identical, but now by putting more event poller into EPU, you are able to reduce the cost for your individual ESM. So just with this feature, you see 70% of a cost reduction just like that. And this is automatic. So if you had a ESM which you were using provision mode, automatically depending upon the traffic, we were able to put more event poller. Of course, if some event poller has a more traffic depending upon your specific workload, then we will not able to put 10 of them. Right? It's the best effort based on your traffic pattern. Second is we are allowing you as a customer to group multiple ESM into the same EPU. So previously, event polar, one ESM, one EPU or more was the pricing concept. Now you can do the grouping of your ESM. So as a part of your experience, you specify minimum number of event polar, optionally maximum number of event polar, and how you want to group your ESM together. By grouping ESM together, you are sharing the underneath the compute infrastructure, the EPU cost that you are sharing across the ESM. With these two capabilities, you can save up to 90% cost reduction compared to this feature before. So now with this, a low throughput ESMs, 1 MB, 2 MB ESMs, throughput ESMs can utilize this provision mode without worrying about the cost. And still you get a low latency for your low throughput ESM, all the advanced capabilities. Again, in the next slide, we will talk about some of the other features that we have launched with that you will get with the provision mode.
So Nihar, just to confirm that as well. So this is separate ESMs. If you have, maybe you've got separate use cases using different filtering or different. Is it even different Kafka sources, for example? What are the parameters with that? How flexible can you get with the grouping? Is it only Kafka sources? Is it only?
That's correct. Yeah.
Okay.
Yeah, absolutely, great question, Julian. So the limitation of for a grouping is that all the Kafka ESM has to be part of the same Kafka brokers. That's it.
Okay.
Now for each ESM, so that means each ESM are polling different Kafka topic. For that Kafka topic, you can have your own filtering criteria, different batching criteria from anyone else. So from an infrastructure perspective, you still have at ESM level, you have all the choices about batching, filtering, schema registration, and validation, very different from any other ESM. The only thing that they are sharing is underneath the compute where your event polar and your ESM is running.
Okay.
Right?
So
and now we are doing the auto scaling of your event polars on the same compute in EPU infrastructure.
So yeah, it's not even the same topic. So you can have different topics in your infrastructure. That could be obviously different Lambda functions connected to those ESMs, connected to different topics. So yeah, a real collection of anything talking to the brokers. I mean, many customers will have a big Kafka infrastructure, and then they'll have they could have hundreds, thousands of topics with shards in it as well. And so you can dramatically save the costs on that. I mean, it's from what I remember, it's a pretty simple way to group them all together.
That's correct. So again, we always work backward from our customers. So many of our customers said, hey, look, we have a teams, typically teams manage around 10, 20, 30 different Lambda functions and corresponding that many topics. We want to save the cost, and some topics would have a 1 MB, 2 MB of traffic, some would have a 5 MB of traffic, some would have a 20 MB of traffic. So how we can optimize our cost, not per ESM but across all this ESM for a given team, or right? So this is the traditional way where customer will say they will create one group per a team or per application. Then now they will put all the ESMs that are processed by within the same application or the same team in the same EPU in shared infrastructure, and they will share the cost, and we will continuously monitor and scale up the EPU. You only focus on to specify, hey, how many event polar you need per ESM distinguishedly, but now we share and sum up everything and scale the compute infrastructure and passing the cost to you.
Cool. I like it. I like the simplicity of it.
Yeah.
Is there anything customers should be aware of? Any caveats? I'm thinking if their capacity runs out, or if they because they've set their minimum and maximum and they need more capacity and they're still sharing. They've got some they're trying to have low throughput or low latency, and now they've got a sort of in a way a noisy neighbor problem. How should customers think about thinking of that?
So in this grouping, you can group up to 100 top ESMs within the same group. Again, we want to reduce the noisy neighbor problem. We don't expect, but again, noisy neighbor, as you said, there is some possibility of a noisy neighbor are there. Now, the way you reduce your noisy neighbor is you specify the minimum number of event pollers that you require for your known traffic pattern. So when I say known, means you have some high confidence idea about how much your traffic pattern you look like on per topic basis, and based on that topic, if you can provision event pollers, the probability of a noisy neighbor reduces, because now the only time that it needs to scale up, and that's when we need to think noisy neighbor happens when all your topics have a spiky workloads at the same time. If they are overlapping, I don't think there would be issue, right? If there when the spike happens and we need to scale up event pollers and the infrastructure, that's when the noisy neighbor issue occurs. So but if you have a warm capacity appropriately provisioned, the probability of a noisy neighbor reduces drastically.
Cool, makes sense.
Yeah, absolutely. So when we launched this capability, immediately a lot of customers saw their bill reduced by 20, 30, 40%, up to 50%. And then now the customer has started doing EPU sharing or group sharing is opt-in. So now you need to do that, specify the group name, and specify which two ESM, 3 or 4 ESMs belong into the same group. So that's a opt-in capability, but high density of event poller is automatic. We take care of on behalf of you. Okay.
Cool.
Next, we will go to error handling and retry capabilities. A customer who are using SQS and Kinesis, they used to using a lot of our excellent retry and error handling capabilities. But for Kafka, we had a gap. So we launched a error handling capabilities and to close that gap. Now we are at par with all the capabilities that we were offering with SQS and Kinesis. Now we offer maximum retry capabilities, a maximum record age. So that means you can specify that for X amount of time, keep retrying. But if the records that are put on a topic are older than X amount, X time, then we put it in a DLQ, right? So you can configure those things. Another capability is retry. When your Lambda function fails, we keep retrying depending upon your retry policies, and we have a capabilities to reduce the with a batch item failure and a batch on function. We have a capability to reduce the retry by identifying the immediately which particular records are failing and whatnot. Another cool capability that we launched is previously SQS, SNS, and S3 were a DLQ destination. Now we allow Kafka topic as a on failure destination. So now if you want to want to use Kafka brokers, same Kafka brokers for both your original messages for topics, and also you want to put the failed messages into the another Kafka topic, not the same topic, but another Kafka topic on the same broker. Now you can configure them. So that's another request came from a customer, and we supported that. We are also going to provide the CloudWatch, additional CloudWatch matrices that's coming in a few weeks, maybe a month or so. It got delayed, but now it's coming very quickly.
Cool, excellent. Okay. Yeah, I think that that Kafka topic is super important, because it means your whole DLQ architecture story can stay all within Kafka, and you don't think, oh, now I need to think about SQS or S3 or that kind of thing. Yeah, and the error handling with batch item failure, that's also such an interesting thing, because a lot of people get stuck when they build streaming applications, and this isn't just MSK and if you've got something, you carry on. I don't want to.
That's correct.
Talk about my excitement about it, but yeah, carry on.
Yeah. So I wanted to show that as an example, right? So when Lambda function is invoked, we do the batch. We invoked with a batch that you have configured. A typically customer configure batch size of 10, 15, maybe hundreds. So we are doing a batch of hundreds or X number of records. Let's say in this example, 8 records. We send it to your Lambda function. Now, if you don't do anything, and if your Lambda function fails, we retry entire batch again, because that's a default behavior for a Kafka and a Kinesis stream and DynamoDB stream. It's an ordered processing. So when we don't know which particular record fail, we retry entire batch again.
And that's deliberate, because the reason you've picked a streaming workload is often because you want that absolute guarantee, mostly guarantee of ordering. And if you think like financial records, or you've got logs that you are writing, or things like that, if you've got a problem and you can't process a message, you don't want to process any more messages. Like, oh, no, stop.
Yeah.
Because I cannot afford to lose a transaction or for it to be out of order. If you think you're using a chat application, I don't know, this could be, I'm not saying they use Kafka or whatever, but WhatsApp or Slack or something. Can you imagine if the messages came out of order? That would be chaotic. And so you'd be looking at them going, that doesn't make any sense. What's going on? So this whole ordering thing
Yes.
is a deliberate part of that. And so there are two parts of it. Is yes, I want to maintain ordering. What can I do? Because the problem is this will keep retrying literally forever until the messages error out the stream. So you literally block all of your processing. You've got provision mode configured, you've got Lambda configured, you've got huge amounts of throughput, and your architecture deliberately saying stop. But there are a whole bunch of things where you do want to do some processing and you're not worried about dropping records. Examples I can think of is, you call a taxi or something and it is sending GPS coordinates of where the car is. If one doesn't come through, 5 seconds later, another GPS coordinate's going to come through. You're going to land up seeing where the car is, or a temperature reading that, happens every second or every minute. If you miss one, it's not going to be a problem. So that's an architectural thing where you decide, do I want to have strict ordering and not lose any messages, or not strict ordering, and then I can do this cool kind of stuff to be able to do things with messages in the queue.
Correct.
Sorry, messages in the stream, not the queue.
Absolutely. So in that particular case, what you do is that in an ESM, you configure that you want batch report item failures. So you enable that mode, and then you need to change your code to specify which particular records are failed. Right. So in this particular example, let's say your record number 3 and a 6 failed. So as a part of your response, you specify with a JSON, hey, record number 3 and 6 are failed. We would only retry that messages. So now your retry has reduced drastically. Now when the 3 and 6 are processed, we see that entire batch has processed, and then we go to the 9, 10, 15, and subsequently. So still the ordered processing is guaranteed, but now you can specify which particular message has failed as a part of your program, your code in your Lambda function, as specify the reply back as a part of your response object. So this is the very cool feature. A lot of customers used it. Now we jumped back a little bit, but let me go back to the another capability, bisect batch on function, right? The same concept, it's ordered processing, but now you are saying I don't need to worry about changing my Lambda function. Can you reduce the retries for messages that are successful, right? And typically what happens is that usually you have a poison pill, a one particular record that is keep failing again and again, and you have no idea, right? So and how you identify that poison pill very quickly. So we actually built this capability where you start with an entire batch. That batch will fail because you are using this bisect batch on function error capability. So first entire batch will fail. So we see that. And when you have enabled this, we say, okay, we don't know which particular message has failed within your batch, but we will partition that entire batch into 2 batches, right? In this particular example, a batch from 8 to 5 and another batch from 4 to 1, right? And now we will do the 2 invokes again in an ordered processing. And we say, okay, one of the batch will succeed and another batch will fail, right? So in this example, 1 to 4 failed. We don't again know. So we will again bisect into 2 batches and keep doing till we identify one particular record that is failing. We will keep retrying it. And then after the max number of retry attempts that you have configured, we will put that particular message, in this example 3, into DLQ, and then continue with the rest of the messages. So by doing this, we are reducing the retries for the successful messages without you writing any code on your side, right? You just need to enable or opt into this bisect batch on function error capability, and we will take care of this error handling capability for your Kafka ESM.
Yeah, and the cool thing is if you look at the 1, 2, 3, 4, 5, 6, 7, 8 in this, what it's going to do is it's going to bisect on the batch, and it's ultimately then going to do 1, 2, and 4, and then only also process 5, 6, 7, and 8. So even though the batch has been split way before the subsequent batches, the ordering is still going to be maintained. And so yeah, that's just something you don't think of, but it's actually clever behind the scenes that the ordering is still maintained from even that the initial batch that was split is sort of held in the system until the other ones can be sorted out.
Absolutely, absolutely. Rohan, do you have anything to show here, or do you want to show the demo next and in the next capabilities that we are going to talk about?
Yeah, we could do it in the next one.
Perfect, perfect. Okay, so next one, which is I think we covered it, is a very big one in my mind. Right, Julian talked about it. I think he brought Lambda managed instances capability a few weeks back. This is one of the biggest capabilities we launched in a Lambda last year. We launched at a reInvent, right? For folks who don't know, Lambda managed instance capability allows you to configure EC2, and you specify EC2 to run your Lambda function. Rest of the Lambda capability works as it is. So now you can utilize specialized Lambda EC2 capabilities, a memory optimized, or a CPU optimized, or a network optimized instances for your Lambda functions, and you can pass those capabilities back to your Lambda. Here you have a greater control over compute that is running on your Lambda instances without worrying about anything about infrastructure. Lambda still provides the serverless infrastructure, but only provides the choice about what specialized compute you want to run your Lambda function on. This additionally drives the performance efficiency. So if it is a better network capabilities, a better cost efficiency by running a multiple requests within the same execution environment. So this is one of the big change compared to a traditional Lambda, where your one request is processed at a time within your execution environment. With a Lambda managed instance, you can process multiple requests at a time. Now, in a context of event source mapping, all your event source mapping that we talked about, whether your Lambda function is running on a default mode or running on a Lambda managed instances, the capability are identical. The only difference now here is your Lambda functions are you running in your VPC on your EC2 instance that you specified. But other than that, whether it is a SQS or Kinesis or Kafka, all your event sources are identically working with Lambda managed instances. Rohan, you have some demo to show that the behavior, how you enable for your function Lambda managed instances. Do you want to take it over?
Yeah, that's right. So if we
Yeah,
can
I'll
share
switch the
my-
screen over. I just the video I was talking about that I messed up that Rohan spotted. I put the link to the video over there. But yeah, Rohan and other people have put a lot of content. There's a reInvent talk which we linked, Serverless Office Hours. Search that up a few weeks ago. It's got lots of info as well. But yeah, I'll switch over to your screen, Rohan. Oh, I need to remove. Sorry. You would think I'd done this before. There we go.
Perfect. Yeah. So as we can see here, we have a Lambda function. And so it's our MSK demo processor Lambda function. Let's just say it's a Lambda consumer for a Kafka stream. And we've actually deployed it on LMI, or Lambda managed instances. And so we can see our capacity provider configuration here that Nihar was discussing some of these concepts. When a Lambda function is deployed onto a Lambda managed instances capacity provider, there's a certain number of execution environments that can be spun up for that Lambda function that are all live whenever a new version of the application is published, rather than on an initial invoke, which means that your cold starts are way down. And so that's, of course, great for those latency sensitive applications. And so we can see various configuration settings that one can apply for their Lambda functions on Lambda managed instances. And so, what I think is so great about putting Lambda functions that are processing messages, whether they're on SQS queues or Kafka topics, is that now you don't have as many cost concerns when dealing with scale. We were talking earlier about, okay, if we're showing this performance test of 2 million messages, and what if you just have millions of messages coming in every day through your queues or through your streams? And so if you have applications that you kept on EC2 all this time because you were worried about what the cost of operating those applications in a modern way, let's say on Lambda, were to be, well, Lambda Managed Instances does solve some of that cost concern for you with the new pricing model that's there. So I think that's a great thing that our customers now have the option to take advantage of the ease of use with the ESM, not only all the features we discussed as far as schema registry and all the polling logic, but the new features as well, such as improved error handling capabilities and routing messages towards other Kafka topics in case of failures. And so that simplified experience is now available at both at scale and at a much reduced cost versus the previous pricing model. So that's another thing that I think customers can really look forward to, is how they can use and take advantage of all these great ESM features with LMI as well. So it's great how Nihar and team have built all these various building blocks for serverless developers and non-serverless developers to kind of integrate together and take advantage of. I'll get off my soapbox here.
Thank you, Rohan. You are absolutely right. I think ESM, event source mapping, and LMI now I think allows you to get this your event-driven workloads with the EC2 like cost model. I think that's the best of the both world. So if you have a net workloads that you have a very high throughput, and you are worried about you are using a specific compute instances for your workloads, now you can have that same choice in a serverless environment. You can now have a network optimized or memory optimized. So this is great capabilities that we are providing here. You are showing a demo something, Rohan?
Yeah, so just to add on to what you said, if customers already have reserved instances and compute savings plans for EC2, they can now apply those to Lambda workloads. It just really helps out with the cost at scale.
Absolutely.
And so what I'm showing here
and
is
these EC2 instances run in your account in your VPC. You can see all of them in your account. You can't SSH into them, and that's a good thing, because Lambda manages it, still does all the OS patching, still does all the management and everything. And we literally deploy EC2 instances, and the function execution environments doesn't use Firecracker, if you've heard about that. For the isolation, uses containers. And so you basically publish a Lambda function to your Lambda managed instances. We stick some containers in, but everything in that we manage, we look after, so you don't have to. But it's awesome that it's in your account. You have full visibility. You've got the pricing things and everything, and it's actually surprisingly simple. You think, oh no, like seriously, I've got to manage EC2 instances. No, you have them. You can get the pricing benefits of them and the sort of fixed model pricing, but the management, it's Lambda's problem. And they do a pretty good job of rolling out software all across the world for trillions of invokes. So hopefully that would work for you.
Yeah, absolutely.
Yep. And here we can see, the features that Nihar was mentioning previously, such as setting the number of retry attempts, the maximum age of records, how you handle your errors with the split batching and reporting batch item failures. In the additional settings page, we can see routing failed messages into another Kafka topic. And so customers, if they're just playing and exploring what capabilities Lambda now offers in the Kafka ESM, they can of course use the console, or all this can be defined in infrastructure as code, such as Terraform, CDK, SAM, or whatever works best.
Absolutely. Thank you, Rohan, for giving a demo. I think, Julian, there is one question from Anderson, and his comment about, hey, provision scaling is great. Do we optimize based on a consumer lag?
So thanks.
Yes.
Anderson, WS7GM, thanks for joining us via Twitch. So there were two messages. Provision mode solve Kafka's latency, but without lag-driven right-sizing, it quickly becomes wasted spend. Optimizing against consumer lag, partitions and batching is essential for cost-efficient scale. So yes.
Yeah, absolutely. So you're absolutely right, and that's exactly what we do with the provision mode for both Kafka and SQS, right? So our scaling criteria is based on a lag. Whether for SQS it's a backlog on your queue, how many messages are there? We look at some of your function durations and say, okay, how this many event pollers are needed, and we scale up 3x faster. Same for a Kafka. Kafka. We'll continuously look at your consumer lag, and based on a consumer lag, we can say, hey, is we try to predict that does existing pollers can handle that kind of a traffic, or do we need to scale up and add more consumers? And consumers is an event poller in Lambda terminology. In a Kafka terminology, it's called consumer as a part of your consumer group. So that's exactly what we do, and we to not waste a spend. We don't want to charge anything extra, not waste any resources, anything that is needed, and that's why scaling faster is very important. At the same time, scaling down if you don't need it. So when you have a spiky workload, scale up quickly and then scale down appropriately. So depending upon 5 minute, 10 minute, we wait for that traffic. Is that traffic sustained, or is the traffic dying down? And then after we scale down, because you don't want to scale up and scale down very quickly also, especially with the Kafka. So we scale down after waiting enough time, some time, like 5 minutes, 10 minutes, and then only scale down.
Yeah, but if you think of, so there's sort of three things to think about, I think. One is you setting a minimum and a maximum amount. So the minimum is, this is the minimum processes I want, so you're always ready to go. You've then got the maximum to say, don't go any more than that. So that's also a cost control and a performance and a back pressure control as well. And then between that, you've got the scale up and scale down. And Lambda basically runs that algorithm for you, because how you're going to have to write something to look at the offset lag, figure out the timing. Lambda's going to do that all for you. And we take, I mean, I know Nihar and the team, work a lot on optimizing that algorithm to save you the money, but also not have to spin down too quickly. Because if you've got a whole bunch of messages, you still want to process them, and you don't want to have the spin down and spin up happen all the time. But remember what Nihar said, it's going to take 5 or 10 minutes. So literally, you're going to have some pollers around. You've got this high throughput thing, and it's going to wait an extra 5 minutes just to make sure. I mean, that is just super adaptive and really great.
Yeah, we even have a customers who are so latency sensitive that they actually set minimum poller equal to maximum poller. They don't want auto scaling, right? Because they don't want any disturbance. They are willing to spend extra resources to say, hey, I need this 10 pollers as an example, and don't scale up. So they set minimum equal to maximum to reduce any scaling, both scale up and scale down. Again, that there are use cases that require that kind of a configuration, and that works for. If not, I think you are willing to take, I think auto scaling will take care of it.
Yeah, and also one thing, if you are thinking, provision mode, it's going to cost me a little bit more money. Yes, it is. But one of the other things with Kafka provision mode is we've also way simplified the networking. So, too complex in the 30 seconds we've got now, but the networking is way simpler. And so we actually take on the cost of a whole bunch of setting up, some of the networking to be able, because obviously the Lambda function's the Lambda service needs to connect to your Kafka topic. It's got to then route it to the Lambda function. It shouldn't be called serverless. It should be called networking less anyway, but we made that much simpler. And so it can actually save you money in certain situations, with the provision mode for Kafka, because it abstracts some of the networking. Excellent. Our time is done. Nihar and Rohan, really appreciate you coming on. I've always, for me, the Lambda event source mapping has been one of the standout things of Lambda, asynchronous processing with all these event sources. And yeah, kudos to you and the team for all the cool things you brought out recently. Super helpful. And yeah, just one quick thing. There's a Lambda roadmap, GitHub. Search for Lambda roadmap. Some of the things we're working on that Nihal's working on are in that roadmap. Send your questions, send your comments, put info in there as well. I don't have time to put a link over there, but yeah, our Lambda roadmap is open source. So yeah, we'd love to get your feedback and information. Nihar, Rohan, thank you very much again. And we also had Kian, his awesome producer. Bye-bye, everybody. See you next week when we're talking about Lambda tenant isolation. Bye-bye.
Thank you very much. Bye.